All right, guys, you're going to add to the notebook again. So a little bit of a funky thing that I'm going to change up. Looking in our notebook, the last pages that we filled out were 114, 115. So let me just go show you what that was real quick. So we had our 114 with this zero product property, and then 115 where we were solving in factored form. Now the very next page we were going to do, but I'm actually going to cut it out. So this 116, 117, we're just not going to fill that out at all. No worries. We'll be fine without it. It's all good. So the pages that we're going to add today are actually 118 and 119. And we're going to talk about solving quadratics in vertex form. Okay, so just like we were doing when we were graphing, as a reminder, we want to graph in each form. So we graphed in vertex, standard, factored. So far we've solved by graphing and then solved in factored. So now we're going to solve in vertex. And the last one we'll need to do next is in standard form. All right, so turning to that page there. 118, there's nothing on it. I'm going to do some separate examples that I'll add as a separate video after this one. Excuse me. So we're going to take a look at this page here, and that is where we will start and talk about how we solve in vertex form. So when I'm in vertex form, if we remember, that's that y equals a parenthesis x minus h squared plus k. So to solve, whenever I'm trying to solve, our first step is to always replace y with 0. Okay, so like this first step here, we want to take y and make it a 0. We need to always be equal to 0 first. And then after that, it's because there's only one x here, we really just need to work on getting it alone like we've solved so many times in the past. So we work backwards to get x alone. And kind of the process that you're going to follow is we are going to first add or subtract k. So to get rid of k, we got to do the opposite. Then we're going to have to multiply or divide to get rid of a. And then to get rid of something being squared, we have to square root both sides. Oh man, my last step won't fit in here. And then the last one is whatever h is, we're going to have to add or subtract that. So this is kind of the process we follow. We first get rid of k, then a, then square root, then h. Okay? It's always better with an example, so let's just jump down here. As we talked about before, guys, when we're discussing the solutions of a quadratic, we're talking about the x-intercepts. And your quadratic could have 2 x-intercepts, so 2 solutions, or it might just boop right off that x-axis once, so it has 1 solution, or it might not touch it at all, so it has no solutions, which probably seems kind of funky, like how could we solve and not get a solutions? We will see. So let's open this up and try it out. I'm going to start on the side that actually has 2 solutions because that's kind of what we're hoping for. Okay, so our first step here has already been done for us. We replaced y with 0. And so then we want to add or subtract to get rid of k. So because it's a minus 15, we'll add 15 both sides. Then we'll have 1/5 parenthesis x plus 3 squared. That's 0. So it goes away and then equals 15. Then I need to get rid of the a value. So I need to get rid of this fraction out front. the way that we get rid of a fraction is we multiply by the reciprocal. So 5 over 1, which is really just 5. And if I do it on one side, I have to do it on the other. So they cancel each other out over here for just 1, which means I don't need it. And we have x plus 3 squared equals 5 times 15, which is 75? 75. Then we need to get rid of the squared thing. So to get rid of something being squared, we square root both sides. And the thing is, this is kind of the thing that we were skipping. Right now, when I need to square root 75, I kind of can't. Like if you check it on your calculator, it's going to be a real yucky decimal. So we're kind of just going to leave that for now. And we're going to put a plus or a minus sign in front of it. Because the thing is, if I had, let's say, square rooted 9 for 3, what it could have been was positive 3 squared for 9 or negative 3 squared for 9. So it could have been positive or negative. So that's why we need to put that plus or minus in front. Now on the other side of this, the square root and square undo each other, and we're left with x plus 3. And then we'll have to get rid of the 3 by subtracting that over. Oh my word, this is not going to fit. So here, 3 minus 3 is 0, and x is alone. And over here, I didn't take the square root of this, so I really can't add or subtract it from negative 3, so we kind of just write it all out. So negative 3 plus or minus the square root of 75. And that's our answer because x is alone. Seems kind of funky. Let's try another. Okay, so our first step is already done for us. We've solved for, we've replaced y with 0. And so now we want to get rid of k. So we'll add the 50 over. And we'll have 2 parentheses x minus 1 squared equals 50. Because the negative 50, positive 50 add up to 0. And 0 plus 50 is just 50. Then I need to get rid of the a value out front. So we divide 2 on both sides. 2 divided by 2 is 1, so that goes away. And we have x minus 1 squared equals 50 divided by 2, which is 25. Which is super nice because now the next step is to get rid of our squared, which we do by square rooting. Square root and square undo each other, so we're just left with x minus 1 over here. And on this side now, I actually can square root. Like the square root of 25 is 5. But the thing is, it could have been a positive 5 because when I square that, it's 25. Or it could have been a negative 5 because if I do negative 5 squared, that's also 25. So that's why we want our little plus or minus in front. Then to get x totally alone now, we want to add 1 on both sides. And now I'm actually going to get 2 separate answers. Up here, I forgot to say, we do kind of have 2 answers. One of them is negative 3 plus root 75. And the other one is negative 3 minus root 75. So we do have 2 answers here. They just kind of look the same, except for the plus and minus in between. These will be more distinct. So when I do a positive 1 and a positive 5, so 1 plus 5, I get an answer of 6. Then I have to do the positive 1 with a negative 5, which is a negative 4. And so then we see that our 2 x-intercepts are at 6 and negative 4. Now, sometimes we don't always have 2 answers. Sometimes we only have 1 answer. So we want to take a look at what that looks like too. So over here, first step is already done for me. We replaced y with 0. And so I'm going to add the 9 away, because that's kind of like your k value. We're just trying to get x alone. And 0 plus 9 is 9. And then we square root it, because there is no a value. And I can take the square root of 9. That is plus or minus 3, which actually has 2 answers, so I'm totally lying on this one. This one has 2 answers. Oh my goodness, of 3 and negative 3. Come on, Missouri. Let's write a different one where we only have 1 answer. 1 answer. Here's the true problem with just 1 answer. Let's say we had y equals 2 parentheses x minus 1 squared. Like that. Okay. Our first step is to replace y with 0. So nothing else changed. We just replaced y with 0. And then there is no k value to get rid of. So I skip that step. I do have an a value though, so I need to divide the 2 away on both sides. And 0 divided by 2 is 0. 2 divided by 2 is 1, so that's gone. Then I need to get rid of the squared, so we square root it. And the thing is, so on this side, our square root and square cancel each other. We have x minus 1. Over here, the thing is, the square root of 0 is just 0. And you could put a plus or a minus in front of it, but kind of it doesn't matter. If I add 0 to something or subtract 0 from something, it's still going to be that thing. So kind of the plus or minus doesn't matter. And then the last step in getting x alone is to add the 1 over. So like 1 plus 0 is 1. And 1 minus 0 is still 1. So really, I just have an answer of 1. Oh my word. This one had 2 answers. I'm such a goofball. I'm so sorry, y'all. Okay, last one to try. Now this one I don't think I goofed up on. So sometimes we won't have any solutions. And so that's what this is going to look like here. So if I take a look on this side, actually I need to distribute that negative 2. So let's do that. We'll have negative 2x squared, and then negative 2 times negative 8 will be a positive 16. And that's because the parentheses are kind of around both those numbers, so I can distribute. With this one, I couldn't distribute because of the squared being outside the parentheses versus this one being inside. Then we just want to work on getting x alone. So I would subtract the 16. And so we'd have negative 2x squared equals 4. And then I divide by negative 2. So x squared equals negative 2. And then we got to square root that. So the square root and square into each other, and we're just left with x. The trouble is, if you try to square root a negative number on your calculator, it's going to get real mad at you. And that's because if you think about the opposite, squaring something, whenever I square something, I always get a positive number. I can't ever get a negative number that has been squared. So I can't take the square root of a negative number. So whenever you have a negative on the inside, that's going to mean that you have no solution. You cannot take the square root of a negative number. So in the next one, we will do a whole bunch more of these practice ones, practicing solving in Vertex Form, just so that we make sure we feel really good about it. See you then.